Now let's understand quadratic equations. What is a quadratic equation? An equation of the form ax square plus bx plus c is equal to 0, where a not equal to 0 and a, b, c are real numbers is called a quadratic equation. Example, 3x square plus 5x plus 6 is equal to 0. Here, the degree or the highest power of x is 2, so it is called a quadratic. And we have the sign of equality, so it is an equation. So this is a quadratic equation. Now, why do we need to solve a quadratic equation? On solving a quadratic equation, we get two values of the variable x which satisfies the equation. Now, the next question that comes to our mind is how to solve a quadratic equation. A quadratic equation can be solved by factorization method, that is, by splitting the middle term, or by trinomial factorization, which you have studied earlier. But it is not always possible to solve by this method. So in such cases, we'll be using the formula method. Now let's look at the formula method to solve a quadratic equation. For any standard quadratic equation, ax square plus bx plus c is equal to 0. There will be two values of x which satisfies the equation. These two values are called the roots of the equation. These two values of x are given by the formula x is equal to minus b plus or minus square root b square minus 4ac upon 2a. That is, the first root is x is equal to minus b plus square root b square minus 4ac upon 2a, and the second root is minus b minus square root b square minus 4ac upon 2a. Here, b square minus 4ac is called the discriminant and it is denoted as delta or capital D. Now, depending upon the value of the discriminant, we get the nature of the roots. Now, let's look at the nature of roots. If b square minus 4ac is greater than 0, then the roots are real and unequal. In this, we can have two cases. If b square minus 4ac is a perfect square, then the roots are rational and unequal. Now, what are rational numbers? You remember that? Numbers which can be expressed as a upon b, where a, b belong to integers and b is not 0, are called rational numbers. Now, if b square minus 4ac is not a perfect square, then the roots are irrational and unequal. What are irrational numbers? Numbers which are not rationals are called irrational numbers. Now, second case could be b square minus 4ac is equal to 0. Then the roots are real and equal. The third case, b square minus 4ac is less than 0. Then the roots are not real, that is, they are imaginary. Also, for any standard quadratic equation, sum of the roots is equal to minus b upon a and product of roots is equal to c upon a. Now, suppose we are given the two roots of the equation. How can we form the quadratic equation using those two roots? That can be done as, let x1 and x2 be the two roots of the quadratic equation which we want to form. Then the sum of the roots s will be x1 plus x2 and product of the roots p will be x1 into x2. Then the quadratic equation can be framed as x square minus sx plus p is equal to 0. Example, if the roots of the equation are 3 and 4, we want to form the quadratic equation. So sum of the roots will be 7, product of the roots will be 12. So the quadratic equation formed will be x square minus 7x plus 12 is equal to 0. Now the prerequisites for this topic are: what are rational numbers, what are irrational numbers, significant figures, how to round off numbers to 2 decimal places, and to find the square root using log tables. Now let's solve some problems on quadratic equations. The first type, solve the following equations by factorization method. The first one, solve x square minus 2x minus 120 is equal to 0. Now here to solve this, we want two numbers whose product is minus 120 and the sum is minus 2. What can the numbers be? For this, we will factorize 120. We can write it as 12 into 10. 12 tens is 120. Now we have in the center minus 2x. Now we take the greater number with the negative sign and the smaller number with positive sign. That is, we have minus 12 and plus 10. So we write x square minus 12x plus 10x minus 120 equal to 0. Now from the first two terms, what is common? We have x common, in the bracket x minus 12. From the last two terms, we have 10 common. We are left with x minus 12. Now factorize them as x plus 10 and x minus 12. Their product is equal to 0. Now if the product is 0, one of them is 0. So either x plus 10 is equal to 0 or x minus 12 is equal to 0. So x is equal to minus 10 or x is equal to 12. Now in this we have to always mention the solution set, which will be minus 10, 12. Now to the next problem, solve 2x square plus 5x plus 3 is equal to 0. Now here again, we want two numbers whose product should be 6 and the sum should be 5. What could the numbers be? Now we have plus sign everywhere. So we can take the numbers as plus 2 and plus 3. So we factorize as 2x square plus 2x plus 3x plus 3 is equal to 0. From the first two terms, we have 2x common, bracket x plus 1. From the last two terms, we have 3 common, bracket x plus 1, which is equal to 0. Now factorize 2x plus 3 into x plus 1 is equal to 0. That is, either 2x plus 3 is 0 or x plus 1 is 0. So x is equal to minus 3 upon 2 or x is minus 1. We write the solution set as minus 3 by 2, minus 1. Here's our next problem. Solve x into x plus 3 plus x plus 3 into x plus 4 is equal to 24. First, we will open up the brackets. X into x plus 3 gives us x square plus 3x. Now multiply x plus 3 and x plus 4 as x square plus 3x plus 4x plus 12, which is equal to 24. Now on the left, we add x square and x square to get 2x square, and 3x plus 4x plus 3x gives us 10x plus 12 as it is equal to 24. Transfer 24 to the other side. We have 12 minus 24, which gives us minus 12. So the equation becomes 2x square plus 10x minus 12 is equal to 0. Now we can divide this equation throughout by 2 to get x square plus 5x minus 6 is equal to 0. Now we want two numbers whose product is minus 6 and sum is plus 5. What could the numbers be? Plus 6 and minus 1. So we factorize this as x square plus 6x minus x minus 6 is equal to 0. From the first two terms, x common, we are left with x plus 6. From the last two terms, minus 1 common, we are left with x plus 6. So we factorize this as x minus 1 into x plus 6 is equal to 0. Now either x minus 1 is 0 or x plus 6 is 0. So x is equal to 1 or x is minus 6. So the solution set will be minus 6, 1. Now to the next problem. Solve 2 into x square minus 5 is equal to x. Now first we will open the bracket as 2x square minus 10 equal to x. Transfer x to the other side to get 2x square minus x minus 10 is equal to 0. Now we want two numbers whose product is minus 20 and the sum is minus 1. What can the numbers be? We know 5 fours is 20. Now which should take the negative sign? Because we have minus x in the center, the larger number will take negative sign. We will put minus 5 and plus 4. So we write this equation as 2x square minus 5x plus 4x minus 10 is equal to 0. Now from the first two terms, we have x common. We are left with 2x minus 5. From the last two terms, 2 common. We are left with 2x minus 5. So the equation becomes x plus 2 into 2x minus 5 is equal to 0. So either x plus 2 is 0 or 2x minus 5 is 0. So x is equal to minus 2 or x is equal to 5 upon 2. So we write down the solution set as minus 2, 5 by 2. Now to the next type, that is solving the quadratic equations by the formula method. You remember the formula? That is, the roots are x is equal to minus b plus or minus root of b square minus 4ac upon 2a, where the standard quadratic equation is ax square plus bx plus c is equal to 0. Now to the next problem, x square minus 15x is equal to 100. Transfer 100 to the other side to get x square minus 15x minus 100 is equal to 0. Now, can we solve this by factorization method? It is possible to solve by factorization method also, but here we are asked to solve this by formula method. So, we compare this with the standard quadratic equation ax square plus bx plus c is equal to 0. We get a is equal to 1, b is equal to minus 15 and c is equal to minus 100. Now the roots for this equation will be x is equal to minus b plus or minus root b square minus 4ac upon 2a. Now in this formula, we substitute the values of a, b and c to get minus of minus 15 plus or minus root minus 15 the whole square minus 4 into 1 into minus 100 upon 2 into 1. Now we simplify this as minus into minus 15 gives us 15 plus or minus in the root we have minus 15 square, that is plus 225. Now that minus 4ac term becomes 4 into minus 100 minus 400 into minus, so plus 400. Now in the root we have 225 plus 400, which gives us root of 625. We write that as 15 plus or minus root 625 upon 2. Now root 625 is 25 because 25's square is 625. We write 15 plus or minus 25 upon 2. Now at this stage we will separate the two roots. We write them as 15 plus 25 upon 2 or 15 minus 25 upon 2 to get 40 upon 2 or minus 10 upon 2, which is 20 or minus 5. So the solution set will be minus 5, 20. Note, in this sum, b square minus 4ac is equal to 625, which is a perfect square. So the roots are rational and unequal. Now to the next sum, solve x plus 3 into x plus 4 is equal to 60. Leave your answer in the radical form. We first multiply the two brackets as x square plus 3x plus 4x plus 12 is equal to 60. Simplify this to get x square plus 7x. Now plus 12 minus 60 gives us minus 48, which is equal to 0. Now we want to solve this by using the formula method. So we compare this to ax square plus bx plus c is equal to 0. We get a is equal to 1, b equal to 7 and c equal to minus 48. The formula for the roots are x is equal to minus b plus or minus root b square minus 4ac upon 2a. We substitute these values of a, b and c in this formula to get minus 7 plus or minus under root 7 square minus 4 into 1 into minus 48 upon 2 into 1. Simplify this as minus 7 plus or minus under root 7 square is 49. Now minus 4 AC term becomes minus 4 into minus 48. That gives us plus 192. So in the root we have 49 plus 192, which is 241. So we have minus 7 plus or minus root 241 upon 2. Now in this case, we are asked to leave the answer in the radical form. Radical form means the root form. So the answer will be solution set is equal to minus 7 plus root 241 upon 2 and minus 7 minus root 241 upon 2.